We just finished talking about our quiet eruptions. We spent a little bit of time on that, and now we're switching to violent eruptions. Violent eruptions are not very common. They make up less than 1% of all the volcanoes. But we're going to spend a couple days talking about them because they're very important. They're also pretty interesting. Okay, they're the ones that explode. They kill people. They damage stuff. We need to talk about them because they are ones that really do affect us a lot in terms of deaths and damage. We want to be able to prepare for them and just learn about them so we can understand them. So your definition for violent eruptions, you just want to say they're explosive eruptions of lava fragments, but not much lava. So explosive eruptions of lava fragments, but not much lava. And we'll talk about what lava fragments are later in this video. So we'll get to that. The next question, though, is why are these explosive eruptions? They're explosive because the lava is felsic. So the why is it's felsic lava. Now, why is it felsic lava? Because they're usually in the continental plates. Okay, so it's felsic lava. And why is it felsic lava? Because they're on continental plates. Now, why does that mean they're felsic? We're going to draw a picture to show that. And there's actually a little blank down below in the stratovolcano part when I talk about this more. But I think it fits in here really nicely, so we can have this video a little longer and then the stratovolcano video a little bit shorter. So find a place on the back of one of the pages to draw this picture. Label the picture. Why don't we label it quiet versus violent? Okay, so quiet versus violent. And we're just going to go over why this difference. So why are quiet volcanoes quiet? Why are violent volcanoes violent? Okay, so we're going to go through that with this picture. So we're going to draw a subduction zone, but we're also going to extend it a little bit to draw a little bit of ocean plate. So here is my ocean plate, and then it's going to subduct down, ocean plate, and it subducts down. I'm going to go ahead and label this ocean plate so that you don't forget. So that says ocean plate. Okay. Then I have my continental plate, so I'm going to put my continental plate here. Notice that my ocean plate is really thin, my continental plate is really thick. Go ahead and label this continental plate. Okay. We talked about this in the plate tectonics unit. Continental plates are very thick, made of not very dense rocks, ones such as granite. So I'm going to go ahead and I'm going to put granite here. Okay, not dense rocks, such as granite, felsic rocks. Ocean plates are thin and made of much denser rocks, such as basalt. So I'm going to go ahead and label this basalt. So we have thin ocean plates made of basalt and thick continental plates made of granite. So now when I have a volcano, so I'm going to put a mantle plume and a hot spot, and it's going to make a shield volcano here. Could be a rift volcano too. I'm just going to say a shield volcano. Also over here, I have my plate melting. Lava is less dense. It's going to work its way up. As it works its way up, it melts in some of this granite, and now it's going to make a steep side volcano. So there's my steep side volcano with some of this lava fragments coming out like that. So we have two different volcano types. We have our gently sloping volcanoes on our continental or on our ocean plates, and our very steep-sided volcanoes on our continental plates. So let's go through and write down this difference that we're seeing. So on the quiet side, our two volcano types are going to be either shield or rift. So I'm going to say shield / rift. Okay, so why do I have shield or rift volcanoes in the ocean plates? Well, the lava is first of all going to be mafic. Okay, the lava is mafic. Why? Because ocean plate made of basalt. So as the lava from the hotspot here is working its way up, it's going through basalt. It's not picking up any silica, so it's not going to get that sticky silica to it. Also, the lava from the ocean plates here is going to be hot. Why is the lava going to be hot? Because ocean plate is thin. So we look at it again here. We have the lava coming up from the mantle plume, the hotspot. It goes through a thin ocean plate, so it's going to be really hot, maybe 3,000 degrees, so really hot. And it's not going to pick up any silicates because the ocean plates are made of basalt. They don't have any of this. They don't have any quartz. They don't have any feldspars. So the lava is going to be very mafic, and it's going to be very hot, and that's going to lead to either a shield volcano or a rift volcano, so it's going to be a quiet eruption. On the other side, we go over here to the violent. The volcano types we haven't said yet, but I'm just going to tell you right now. We're either calling that, it's either going to be a stratovolcano or a cinder volcano. So strato, oops, or cinder. That says cinder. So stratovolcano or cinder volcano. Well, why is it going to make a strato or cinder volcano? Well, one, because the lava is going to be felsic. Why is the lava felsic? Well, it's felsic because the continental plate is made of granite. Okay, it's granitic. So there is lots of silica that it can work in. So as the lava rises out here, it's melting in lots of quartz, lots of feldspar, so it's getting very rich in silica, very felsic. The lava is also going to be cooler. So number 2 is cooler. Uh-oh, lost it. There it is. So lava is going to be cooler. Why is it cooler? Because continental plate, I'm going to abbreviate, continental plate is thicker. We look at it again. The lava melts here, it goes through a lot of continental plate. So by the time it gets to the surface, it's going to be cool. It's also going to be rich in silicates, so it's going to be felsic. That's going to mean it's very high viscosity. It's going to lead to steep side volcano that's going to be very violent. The gases aren't going to be able to escape because the lava is very high viscosity. The lava is going to trap the gases in. On the other hand, in the ocean plates, the lava is going to come right up. It's very hot, it's very mafic, the gases are going to bubble right out, and you're not going to have violent eruptions. The lava is just going to come and flow right on out. Okay? So very different types of volcanoes depending on where these volcanoes are located. If they're located on ocean plates, they're most likely going to be quiet, shield or rift. If they're located on a continental plate, they're most likely going to be violent, cinder or a stratovolcano. And we're going to go into these cinder and stratovolcanoes in the next lesson. The last thing that we're going to talk about, though, for this lesson are these lava fragments. We had our definition, and we said it was explosive eruptions of lava fragments, but not much lava. Well, what are lava fragments? Here they are. Lava fragments, they're called pyroclastics or tephra. It's the general term for all erupted material that isn't lava. So tephra pyroclastics, the general term for all erupted material that isn't lava. I tend to use the term pyroclastics. I just like it better. I like the kind of etymology. Pyro, fire, broken clastics. Okay, so it's broken fire. I just kind of like how that sounds. So I usually use pyroclastics. But tephra is fine to use also. There are 4 types of pyroclastics. First one you see is ash. Ash is the smallest. Diameter is less than 2 millimeters. So smaller than sand size. Lapilli is the second smallest. Diameter between 2 and 64 millimeters. So sand size up to 6.4 centimeters, so bigger. Block is the biggest type of tephra. It is greater than 64 millimeters in diameter. So it can range anywhere from that 64 millimeters up to the size of a car, or sometimes even to like kind of the size of a small bus. You might have that big a piece flying out of a really violent eruption. So those are kind of our 3 main types of pyroclastics. You see though that there's one left on your note sheet, a bomb, so a volcanic bomb. Volcanic bomb is a little bit different. So these are all the same except for size. Volcanic bomb is a little different. Volcanic bomb was erupted as lava, but cools in the air and falls as a solid. So erupted as lava, cools in the air, and falls as a solid. So when you look at volcanic bomb, it's usually fairly rounded or spindle shaped. Okay, so it's kind of rounded or spindle shaped because it was still a liquid lava when it was erupted and then cooled in the air and fell and kept its smooth or rounded spindle shape. Last, let's show a couple pictures before we're done with this one, showing some ash. This is in Japan, obviously, and we see the ash clouds in the sky before it comes down. Now you see the ash has come down. It looks almost like snow. Why is it so light colored? Well, because it's very, very felsic. Remember, felsic lava is very light colored, rhyolitic. Okay? You're going to have, with these violent eruptions, this very light colored, very felsic ash. You can see these ladies have bandanas covering up their mouths and nose. Because you don't want to breathe in the ash. This is a blown up picture of it. It's not nice and round. It's jagged. You don't want to breathe this into your lungs because it can damage your lungs. And there's another picture showing kind of what it might look like the ash is going up in the air. You also want to clear it off the roof of your house because it can build up weight. If it rains, it'll absorb the water and be like concrete on top of your house and can collapse houses that way. We're going to see some ash from Mount St. Helens. I'll bring some of that in. And you're going to see that it is also very light colored because it is very felsic, very violent eruption. Okay, that's it for our intro on violent eruptions. Then the next lesson we're going to get into our stratovolcanoes.